Hello. Pardon.
Brandon, is that you?
That is me.
Nice. Hey, how are you doing?
How's it going?
I'm doing all right. Doing all right. How about you?
Oh, doing good. Same old, same old.
Mm.
Yeah. Yesterday, Jamie came in and gave the Newton tutorial.
Great.
Yeah.
So everyone's set up to log into Newton.
They are. Yep.
Great.
Yep. Everybody's got the VPN. Everybody's set up with Newton. He showed an interactive example. So
Cool.
Yeah. So did you apply to grad school? Are you in grad school now?
I'm graduating this semester, but I'm going to UF for grad school.
Good for you, dude. That's
Yeah.
great school.
Yeah. So yeah, this is wrapping up my last semester. So
Yeah. So what program are you going into?
it's a lab that deals with AI in the medical field. So like more application research of using AI to improve like hospitals, especially with the large focus on like ICU rooms and stuff. So they're doing a bunch of things like patient trajectories, like how if they get sick or after surgery, like how are they going to recover or what's going to happen. Things like pain management, and like how much pain medicine to give to somebody based on how much like pain they're in and stuff.
Give me all the pain medicine. Just
Yeah.
I
Right. But yeah, so I'm
almost
excited
got
to do
recruited. A guy tried to recruit me like a week or two ago from care.ai.
Care.ai. I haven't heard of that.
Yeah, I don't know if you ever heard of it or not, but basically they're using computer vision to determine like statistics on patients in the room. For example, did a patient try to go to the bathroom and fall over?
Right.
Have they been in the same position for too long and they're going to get bed sores? That kind of stuff.
Like an automated nurse.
Kind of, yeah.
That's
Yeah.
cool. Yeah. Yeah. I'm hoping to do some more application based research with AI. So I'm excited to do that.
Me too, man. That's great. I'm happy for you.
Thanks.
Yeah, Dr. Lobo was asking me, and I was like, I'm not entirely sure.
Yeah. Yep.
Let me see who we're missing here. 1, 2. Who's 3? Sunjay, Tess, who's number 3?
Robert Lake.
Robert Lake. Okay, thank you. Number 5. Tess, I always hear your accent. It reminds me of my mom.
Is there somebody's in Minecraft? Good background. Appreciate that background. My background doesn't work, so I just get a cool wallpaper.
Yeah, right. 1, 2. Robert Lake's missing 4. Chu Chen.
Is the REU completely online this semester again?
Yeah. Who else is not here? Is Brian Modica here?
Yeah, I'm here.
Good, thank you.
I think the last person just joined.
So
Brian's
Brandon,
here.
how's the AI club?
Brian is here.
So Brandon, how's AI club been going?
Pretty good. I mean, the last semester was the last semester for the leadership since I'm graduating. So we've already handed it off to the new leadership. But I mean, I really enjoy doing the DBMs and stuff. So that's I mean, yeah, I say pretty solid. I'm hoping in the fall they're able to bring back more and stuff. So which is the plan. I get that revamp core out. So yeah, I'm excited for. I think it's gonna keep getting better. So
Brandon, I don't see the last person So I'm gonna just go ahead and let you go ahead and get started.
Oh, okay.
Yeah.
Sure.
I'm gonna take care of some other stuff, but I'll be around. So if you need me, let me know, but I don't think you will.
right.
And then just, you have till 11:30 today, till today.
11:30.
Don't feel like you need to take all of it if you don't need it, because we have another
I'll
session tomorrow.
Probably need most of it, so. we'll be
Okay,
all right.
that's good. All right, I'll see you in a bit, okay?
All right. All right. Well, welcome everyone. My name is Brandon Silva. So I did the REU in 2019. And for over the last year and this year now, I'm just helping out with some of the Linux stuff, because especially during my REU, there was a lot of issues with working with Newton and the command line and stuff. So hoping in that to help improve that and get everyone acquainted with some of the technology that we're using this semester. So a little bit about me: I'm a computer engineering major. So like I said, it's my last semester. And I'm going to UF for my PhD in the fall in computer science and engineering. So yeah. So today we're just going to go over the basics of the command line. So really, tomorrow we'll get into all the Newton specific stuff with setting up your environment using Newton. And so today will just be just all very basics command line stuff. And they have access to those write-up files. I hope you guys do for that repo. So I'm just going to be following the tutorial in those markdown files for the Linux GPU cluster tutorial repo. So all the information I'll be going over will be in there. So first things first, who has has anybody have any familiarity with the Linux command line? Okay, so a few people. Okay. Well, then this might be a good refresher. If you do not have any experience, in the file, there are links to the cheat sheet, which you guys should open up now. And I think I can copy here. Let's see. Yeah, so that was there. So that's a cheat sheet that has like a bunch of commands and stuff, so you can have that up when you're going through this. There's also, I also link a quick a course to Code Academy that has a lot more in-depth learn the command line, like kind of class thing set up. So it's a pretty good introduction. If you feel you need some more help, some more practice. All right, so I'm just gonna follow along. It's gonna be interactive, so
Hey, Brendan,
yeah.
I hate to interrupt, but that first link you sent seems to have an error, or at least it had an error when I clicked on it. Maybe I'm doing something wrong.
Yeah, I got the
Should
same
be.
thing.
Let me see. Oh, okay. So it's not there anymore. That's not good. I think because it was a new repo, he moved everything over. Let me. Okay. So the cheat sheet has been since destroyed. All right. Well then, that's the repo with the thing I'm following, but I need to get the cheat sheet. Let me just see real quick if I can find it without wasting too much time. There's plenty of cheat sheets online. I think this is the one I actually use. We'll go ahead and throw that in there. Yeah, I need to re-add that PDF because it looks like you've moved repos. But I think that's yeah, it seems to cover pretty much everything. Nano, screen, IL, file operations, yeah. All right, so that should be pretty good. There's like tons of cheat sheets. You can just Google Linux cheat sheets and bring up a couple if you want. There's a mind-boggling amount of them. So, but that looks pretty good for. I think that's actually the one that I had saved. That link saved. All right. Sorry about that. All right, so like I said, this is going to be a interactive tutorial, so you guys should all be able to log into Newton and be on the UCF VPN right now. So as you see here, I'm going to be screen sharing my terminal window. We're all going to be doing this from Newton, so we all have the same environment that we're working with. So there's not any issues with different setups and stuff as we go through and use these commands. So go ahead and open up a PowerShell if you're on Windows 10 or a terminal if you're on any other operating system. And go ahead and we'll SSH into Newton.
So are we supposed to open this one in our like on computer's PowerShell, or do we do it with the VPN stuff?
What was that?
Oh, sorry, never mind. I think I figured out.
Oh, okay. Yeah, everyone should be able to log into Newton. And if you follow the tutorial that I had, you should just do SSH Newton because it's already saved with everything. And then you should see the welcome message. And yeah. So is everyone in Newton? Very important. If anyone's not in Newton, please let me know now.
Just signed in.
I have to get my passcode. It's on the files, right?
What files? What?
The passcode to log in or whatever. It's I need to get it real quick.
It uses a key file to log in. It shouldn't ask you if it's asking for a password to log in. I don't think, unless things have changed, but
Yeah, that's what I mean. I'm sorry.
oh, okay. All right, yeah. You can actually if you so on that repo is the Linux repo. If you follow the number 1 with that has the DPU setup or the Newton setup, you could decrypt your key file so you don't have to keep entering in the password every time you log in for the decrypt the key file. And it goes through the steps to decrypt that. So you can follow that if you want outside after this to get that set up.
Okay.
Yeah. So here, if you could use the little Zoom feature to raise your hand, and if you're not logged into Newton, raise your hand, or if you're having trouble. If I can see. All right. So we have 2 people having issues. All right. So what's going on? What's the error?
I'm trying to do mine from scratch again because when I'm using the same command I did yesterday, it's saying could not resolve hostname Newton.
Are you on the UCF VPN?
I think. Let me see if it disconnected me.
Yeah. Got it. You have to be on the UCF VPN. 2 is, hope I said that right. Yeah.
I got the same problem. I typed in SSH Newton on the PowerShell and I could not resolve hostname.
Did you guys follow the tutorial that I had set up to get logged into Newton? Or no? You went through like what Jamie set up for you?
Yeah.
All right, so however you logged into Newton last time or yesterday, you follow that same process. It may be different for you.
Yeah, I think
So that's
because
fine.
we use mobile extern.
Oh, okay, yeah. Yeah, if you set it up with mobile extern, please go through that because it's not going to work through this. I was just following the tutorial that I made to get set up with Newton, which is number 1. So it's just things were a little bit different this year because you had some help from Jamie. So yeah, please use mobile extern or whatever system you had set up to log into Newton last time. Please follow that same system or that same commands and stuff to get logged in. And looks like everyone else. You having some trouble, Michael?
I just did it. I finished.
Okay.
Sorry.
All right, good. All right, so you guys good now? Logged in? Yes. All right. 2, are you good? All right, Brown's good. Michael Brown's good.
Yeah, I'm good.
Great. All right. All right, well, that's the hard part. So now that we're all logged in, you'll be greeted by this message. So your terminal might look a little bit different how you set up, but everyone should have like the same type of prompt. So now we're all logged in. So a little bit about the command prompt. I'm going to be using the words command line, shell, terminal, bash interchangeably. Each of those words have specific definitions that are different. But for this tutorial, let's assume that these all kind of mean the same thing. Like you have a terminal, you have a shell. We're going to be referencing this, the command line here. So your command line, you have your prompt, which is here. So the prompts can be very different depending on what systems you use. But typically you'll have your username at like whatever the computer name is. So this computer name is EVUser1. And then you will have a little thing. This shows like what directory you're in, which we'll talk about. And then just a little $sign to show this is to provide space between your prompt and where you type. So without further ado, if this is your first Linux command, let's run our first. We gotta do our hello world. So go ahead and type that in and run that. So echo just echoes whatever you type to the screen. So just kind of like a print function. So it's very useful for appending the files and stuff and used in scripts, which we'll talk about later. But yeah, so there's your hello world for the first time if you haven't really ever used Linux or the command line. So yeah, so this following that process, your command line interpreter, you run lines and press enter and you run each line one by one. And then there's scripts that can run multiple lines, commands in quick succession, which we'll talk about a little bit later. So first off, we're going to go into file and folder commands. So just talking about directories, how to navigate through the file system and everything from the command line. So your command line has a sense of location. So, you're always in some type of folder or file. Like in a file explorer, you click through some file folders and then you're in some folder right now. It's the same way in the command line, but it's less graphical. So I want to know like what folder I am. I can do pwd, press enter. So this is print. This is for a print working directory. So directory is just another name for like a folder, your directory or path. And then the path is how you get to a directory. So this is your path. So right now, the folder I'm in the file system is home B Silva. And now, if you're not familiar with like the Linux file system, compared to Windows, Windows use backslashes and then you start with like C and colon and then have some backslashes for things. Linux is a little bit different. So your paths use forward slashes for each directory level. And for the first forward slash is called the root. So the root is like, it's like your C drive. Like when you just double click in the C drive and you see program files and stuff, that's like the root of Windows. In Linux, the root is just a single forward slash. That's the root of your file system. So right now I'm in the home directory and I'm in B Silva. So this is kind of like the user directory. This is where I am. And everyone should be in home and then whatever their username is. So that's where we know where we currently, that's where we currently are. So now we're like, okay, well, I want to know what's in here. So ls will list our files in the current directory. So when I do ls, you can see I have a bunch of files. You probably might not have any files or just have like one file or folder. So the blue here are folders. And then the green here are scripts. And then you'll also there could be some other files. So, but that is this listing like what's in your current directory. And let's go ahead and if you want it. So now that's just a simple like command ls. Okay, what if I want to know if there's something in, let's just say the scripts directory or my environments. So I can type ls and then the directory and I could see some more folders in this folder called my environments. So I want to break down what happened here is that what I did was is that it just ran a command by itself, and it did some stuff. Now I ran this command and I passed it an argument. So you'll see these a lot with commands that you're going to have arguments to them that do different things. So just keep in mind if I use the terminology arguments is what I mean, like arguments to the program. So ls is the program I ran, and then an argument, I pass it this directory to list the files and folders in this directory. Now, ls by default, I don't know if everyone knows this, but like on Windows 2, there's hidden files. So when you go through your file explorer and stuff, there's actually files and folders there that you are hidden. And you actually have to do some extra steps to unhide them to see them. That are just like a bunch of like setup or configuration files and folders that, you know, that you don't really need to normally edit or go to. So in this case, in ls, if I want to know what hidden files are in this directory, I can use ls tick or dash. I'm going to call these ticks, but we'll call it dash or the minus sign here. A, press enter, and now I'm going to see a bunch of files with a dot in front of them. So in Linux, when you put a dot in front of a folder or a file name, it hides it. So when you do ls, you don't see it, but if you do ls.a, you'll see it. So now if you don't have any folders or files, when you do ls.a, you should see some files, because everyone's going to have a bash history, bash profile, bash rc. These are just configurations for your terminal and stuff, which you can learn more about on your own, but a little bit too much right now to talk about that. But now I want to talk about this command here. So what I did this, now when I did this tick A, this is called a flag. So a flag is like turning on some option. So I didn't really provide it an argument, like I didn't give it a directory or anything like that, but I said, I told the ls program, hey, I want to see hidden files. And so if you look at, we'll talk about getting help or figuring out like what a program can do later. But the ls command has documentation saying if you want to look at hidden files, you type tick A and pass it into the program as a flag. So it's like turning something on or off. So we'll be using flags and arguments to run our command line programs throughout any program you're going to be using on the command line. So now we're able to see all of our hidden files and stuff that are in our directory. So when yes, so if there's also other flags you can do. So you can do ls.asl, which will list everything in the directory and also who owns it and permissions and stuff. I'm not going to talk about like what these permission means and things like that, but there's other things you can do to list. So I'm going to list, so I do ls.asl, I'm going to see all the files in the directory, plus their permissions, their file size, and a bunch of other information. So you can learn a little bit more about permissions and stuff in a different tutorial. Yeah, so that's for listing directories. So now we know where we can be. So pwd, we can see where we are, and we can figure out what's in here with ls. But now, what if I want to move directories? So before we go into talking about changing directories, as I explained before, you have paths here, and these paths will allow you to move, like say, like where you want to go. So you see here, I have home, B Silva. So if I want to go there, I'm going to use a command called cd, which stands for change directory. So let's say, for example, I want to go to home, B Silva, and then I want to go to my environments. I'm going to cd and then press enter, and you can see that my bash prompt updated to my environments. And if I do ls, that I am in this directory now. I'm no longer in this home directory. So if I be pwd, you can see I'm now in this directory. Now, I'm going to go over this command like later, but just so, because I don't know if everyone has folders, probably not. Let me, if everyone types make directory, let's just create a test directory, like test. This is for making directories. It's like creating a folder, but this so everyone can practice the CD. So now if we do pwd, we'll see here. So I want a CD to home, B Silva, and then now I just created the test directory. I'm going to CD. And if I do ls, there's nothing in here because I haven't created a folder. But so is everyone good with changing directories and understanding how the paths work? Any questions? Feel free to stop me, or you can use the Zoom, like raise your hand because I have the participant thing open, or just interrupt me if you want. Like, perfectly fine with that. If you have any questions or anything. All right. Well, that's for navigation. But now you're like, okay, well, I can navigate, sure, but am I really gonna have to type this home B Silva and type all this stuff? And it's get really tedious real fast. Like, I don't have to keep typing all this stuff every time I want to change the directory. And thankfully, you don't have to. So there's a thing called absolute paths and relative paths. So what I used here is what's called an absolute path. So an absolute path meaning this is the entire path in the file system from the root to wherever folder I'm in. So if you're in Windows, you can look at it like when you're navigating through your files, you can see at the top bar, if you click it, it'll say like C users, your username, desktop, some desktop file, like if you're on your desktop. So that's a full absolute path. And there's things called relative paths. So a relative path is a path that is relative to where you are in the file system already. So let's just say, for example, so let's so right now we're in this test directory here. And we could see that, okay, well, now I want to get back to my home directory. Well, I could do cd.home B Silva, and now I'm back in my home directory. But instead of doing that, I can just simply do, if I cd back in a test, your home directory, in pretty much every Linux operating system is dictated by this little tilde. So you can always do cd tilde and it will always bring you back to your home directory. Or you can just do cd and it'll always bring you back to the home directory, as you can see here. So now if I want to cd into that test directory, I don't have to type the whole path. Since I'm already in my home directory, I'm already in home B Silva. Let me just make sure. And I know that there's a test directory here if I do ls, so I can see the directory test. I can just do cd test, and now I'm here. Instead of it's not relative, because I went to relative to my home directory. And then no matter where you are, you can always cd to come back home. So yeah, so it's very important to understand relative paths and absolute paths, because especially when you're writing scripts or you're trying to reference other files and stuff like that, you could very easily have a lot of issues with file not found and things like that if you use depending on if you use relative paths versus absolute paths and things. Because like if you want to run a command that uses a relative path but you're not in the right directory, then it's not going to find the file. You'll have to change your relative path because it's relative to where you are. So it's important to keep in mind where you are. And in pretty much every type of terminal, in your prompt, it'll have some type of indication of where you are in the file system. So to help you out. And you can always do pwd to figure out where you are as well. Any questions on that? No? All right, and so you can also combine relative paths together. So let's just say I'm in my environments. I'm also going to clear my terminal here. So you can do clear just to clear out everything like this, get a clean site. So let's say, I'm in the my environments folder and I'm like, okay, well, I want to go to my test folder in my home directory. Well, I don't want to have to cd to my home directory first and then cd into test or hard code the path. So what I can do is I can do cd. I know that the tilde is my home directory / and then I'm going to go to the test, as you can see here. So the relative path is my home. here and then do that, and it can be real easy to go into my test. So like I said, you can always use tilde to get to your home directory. So no matter where you are, you can use tilde and then access some file, and you can cd into that real quick. So now that we could talk about what that we're inside a directory. Now, what if I want to just go up and down a directory, like in File Explorer, you can click like the little up arrow to go up a level and stuff like that. What if I want to do that instead of having to like cd like and type the whole relative path again or something like that? Well, if you do ls.a, you'll always see two directories. You'll see dot and dot dot. You'll always see that if you do hidden files. So what is this? So dot actually references the current directory. So if I do cd dot or ls dot, I'm going to stay in the same directory. So you use the dot to signify the current directory you're in. Now dot dot, what do you guys think that might be?
One level up.
Yep, exactly. So dot is our current directory, but I can cd to dot dot, and that brings me to one level up. So let me make another directory. Create just to navigate into here to show you that. So right now I'm in home test2, and I'm going to cd to dot dot, and now I'm in test. I just went up one, and then I can go back to test2, and I can come back. So that's and you can also combine this with relative paths. So let's just say I want to ls my home directory, but I'm without using the tilde, I can do ls dot dot. Actually, you can see here, it went up, it did the list of files and folders in one directory up. In this case, it's my home directory. So you can use these as relative paths to see fit. Or say if I want to, if I'm in test2, I want to cd to dot dot slash dot dot. This will actually bring me up one level to the directory and then do another level, which in this case, going up 2 levels brings me back to my home directory. So these dot and dot dots can be used in your relative pathing. And yeah, I mean, that's pretty much it. You have dot and dot dot, and you can move around using those type of relative paths. So yeah, I mean, that's pretty much it for that, for navigating that file system. So I think that wraps up navigation and file pathing and stuff. Any questions on any of that stuff that we just talked about? File path, file moving around the file system, figuring out what's in there, knowing where you are. All good? Great. You'll learn these commands pretty quickly because you're always going to be needing to move around in directories and stuff. So you'll pick up the stuff. And that pretty much goes for the entire Linux command line. Like if you really, it just comes with practice and just remembering commands and stuff and just knowing how to move stuff. So, you know, it's pretty easy to pick up with practice, which you guys will have plenty of over the summer. And that's why I recommend, if you're not on a Linux operating system already, I highly recommend setting up like a dual boot or some type of, there's also Linux file system or Windows file something for Linux or for Windows.
Windows subsystem for Linux.
Subsystem. That's yes, the subsystem. In that repo I sent, or this cluster tutorial in part 1, I think there's a link in there to setting that up. But I highly recommend going forward into the REU to set up some type of Linux operating system, so you'll get a lot of practice, not only using Newton, but on your own system using these commands and stuff, and you'll pick it up real quick. And it's good skills to have. Yeah, that's and also like setting up dual boot and stuff is really good experience, learning a little bit more about operating systems and how they work and how your system boots and stuff like that. So cool stuff. All right, so now you're thinking, okay, well, you know, I have to type all this stuff out. You know, typing is really hard. You have to lift your finger up, you know, put it down on that key. The keys are sometimes really hard to press. They get stuck, you know, it's really hard to do. So we want to limit, as we limit the amount of keystrokes we have and save some time, it'll add up over the course of your life, and you'll save, you know, a couple hours at the end of your life, you'll have extra because you use all these shortcuts and on the command line and stuff. So in pretty much every operating system using command line, we have what's called tab completion. So when you're running commands or typing things up, you can press tab and it'll try to auto complete what you're trying to do. So for directories, let's just say CD, and I want to type T, and I'm going to hit tab. And as you can see, right when I hit tab, it auto-filled to test the directory that I want to CD to. So I just saved the type 1, 2, 3, maybe 3 to 4 characters. So saved a couple microseconds. So that'll add up. But you can pretty much for any type of command, any type of thing, you can always try to use tab, and tab will auto-complete whatever you're trying to do. So I want to CD T, and then I'm going to type test, and I can also type TE tab, and I'll just do that. If you have multiple files, so let's see. So let's just do LST. If I do ls test and I hit tab and I hit tab twice, you'll see that it'll actually give me the options for auto completion. So either this file or this folder for ls. When I CD test, I can't CD. What's cool is, as you can see here, it gave me multiple options. But if I type tab here, it fills in test because I can't CD into a file. And so your terminal will realize that. So when it auto completes, it's not going to auto complete with this file or try to CD into a file because that's an invalid argument. So your auto completion will actually give you that will only autocomplete valid arguments, so it helps you out of it. So it won't try to autocomplete with something you can't do. So we could CD into that. So we'll CD back. So if I want to ls, like I have my environments, I can just type M and type tab and autocomplete. So you can pretty much autocomplete everything. And it's not just for directories, like I said, like when you're using programs and stuff, anything you can autocomplete with. If you press tab. Like installing a program, if you press tab, it'll search the package directory and figure out like what packages have that name. Like if you're installing a package on your local computer using the command line, like anything can get auto-completed. It's very, very useful. And you can also hit the tab key multiple times if there's multiple options. Like when I did the ls test, it says test, but if I press tab like twice, you'll see that it'll give me options for that multiple options. So yeah, and you'll see that it'll basically autocomplete up to that point. So autocomplete the test. So I can choose test.sh or just leave it as test. And it'll give you the option where you can go forward with. So if I do if I type dot here and then type tab again, there's only one thing that is test dot, and it'll fill in the sh. Yeah, so always use tab when in doubt, and it'll help save some keystrokes. But don't use it. Yeah, you got it kind of takes some practice to use it a little bit more effectively, but like, you know, because if you have a lot of files or folders that kind of start with the same letter or something, you're gonna want to type a few more letters and then tab to make it quicker and not have to like look at your options and figure it out and do that. So, but that just comes with, like I said, practice. Okay, so yeah, I mean, that's pretty much tab. Any questions on tab completion? So now let's talk about canceling stuff in the console. So say you're running a program or you type something out, like, you know, I CD and I'm typing out like a really long directory, and you know, I'm like, wow, okay, this is wrong. I don't want to have to hold backspace. Too much time. Very sad. So if I have something like this and I'm like, oh, I want to cancel what I'm doing, and for a terminal, pretty much anything, if you want to cancel what you're currently doing in the terminal, your shortcut is Control-C. As you can see, you actually get a little sad face because Control-C will just terminate. It's like a kill. Will terminate anything going on. So in this prompt for Newton, it actually will give you a little sad face because it's like a crash or something, or sees it as a crash, but it's not. We just canceled it. But yeah. So you can Control-C all you want, and it'll just cancel and give you a new fresh line here. And this also goes for running programs too. So if you're running a program that's taking like a long time to execute, it's doing a bunch of things like a Python script or something, and you want to stop it early, you can just do Control-C and it'll just kill it. and it'll kill anything. But you got to remember, this is not a clean exit. Like I said, this isn't like, you know, pressing X on the window and it closes down all nice and neat. This is a kill. So like, this is not a clean exit. If your program's doing something, it'll just stop execution. It won't clean up or do anything. So just keep that in mind when you're control seeing, like running programs and stuff, that it's like going in a task manager and pressing end process a bunch of times until it closes. It'll close the program. And so that's just cancel. Also, and then you're thinking, okay, well then how do I copy and paste? Because I have to, if you try, you know, you'll probably mess up a lot if you're trying to control C something in here. Like I want to copy this and control C. I actually just cancel what I'm running. So you can right click in your terminal and do copy and paste. But for the terminal, if you want to use the keyboard shortcut to copy, you do Control Shift C and then Control Shift V, and I'll actually paste that. So I actually did Control Shift C to copy this and then Control Shift V to paste it. So you just need to add Shift to Control C and Control V to use those keyboard shortcuts to copy and paste. Keep that very much in mind, because you don't, when you're copying something, you don't want to have your program running for 3 hours, is about to finish, and then you do, oh, I want to copy this, Control C, and then you just destroy everything. So I've done that a lot. Just don't do it. Keep that in mind. Think about it before you copy. So, all right, I'm gonna go ahead and clear this out. So I talked about a little bit about so I'm going to be switching into file creation and deletion and all that stuff, like managing your files. So I saw, so you already saw the make directory command, which I just did. You know, make directory test3. So that creates a directory. Just so I kind of reached out a little bit earlier, but that's what it does. It makes directories. You can't make a directory that's already there. It'll give you an error saying that the file exists. So can't have directories with the same name. Directories are also case sensitive. So make directory test3. We have 2 different directories, so they're case sensitive. So make sure you keep that in mind when you're creating directories.
Brandon?
Yeah.
I just tried the Control Shift C to copy in MOBA Xterm, and it canceled rather than.
They did?
Yeah.
Same here. Same with me.
Okay, well, I've never used MOBA Xterm, so I'm not sure. Trying to think, maybe there might be a different keyboard shortcut that MOBA Xterm uses to do the copy. Usually on pretty much any Linux or Mac OS system, it's Control Shift and C and V to do that copying. So I'm not sure on MOBA. You might have to look that up. I couldn't tell you off the top of my head because I never used MOBA, but there's probably a different keyboard. Maybe you could try Control C.
The mouse does work though, using
the right click. Yeah, the copy. Yeah, but that's slow. Too many button presses and mouse movements. You gotta be quick. Save those seconds of your life. But yeah, you'd have to just look up keyboard shortcuts for MOBA Xterm. I'm sure it's probably like Control Alt C or something else. You have to look that up. But if you're using a Linux operating system or the Linux subsystem or something, I think it should be Control Shift C and V for doing that. All right, any other questions?
Oh, paste is Shift plus insert. If you just right click, it has the shortcut next to it. Paste is Shift plus insert. And MOBA Xterm.
Just Shift Enter?
Shift plus insert.
The mouse button, the middle mouse button, is paste as well.
It's
I'll take that. Okay. Huh. Well, the more you know. I didn't Shift Enter. That's kind of an odd.
Shift
no.
insert.
Shift insert.
Oh, Shift Insert. What? That's okay. I guess okay. Well,
Hey, I
it's
didn't
kind
write
of
this.
unconventional. Yeah, that's a little unconventional, but okay.
Yeah, it worked.
Okay. Okay. Cool. Well, there you go. For if you're using MOBA Xterm. Reality is upgrade to a better operating system. That's okay. Which is Linux. Dude, Arch Linux is a superior operating system, right? Now, don't use Arch Linux for your first operating system. You're gonna hate yourself. This Ubuntu is pretty good for your first OS. But I recommend not using Ubuntu long term because it's kind of filled with bloatware and stuff too, sadly, because it's Ubuntu. But it's pretty easy. Anyways, all right, let's get back here. All right, so let's talk about creating, removing, managing files. So let's say I want to create just some regular files. I know how to create directories, but I want to create a file. I want to create a file, some type of text file. I'm going to do touch. So touch allows you to create a file, an empty file. So I'm going to create a file called my text file .text. I'm going to give it the extension. Now you got to remember the terminal will just do everything. It's not like Windows where it likes to hide your extensions and stuff. You're going to see the extensions of everything, and you're going to need to work with the extensions of files. So I gave this a .text to give it a text. But sometimes your extensions don't really matter. The extensions help for programs and stuff to know what the files are, and also like your command prompt to know like what files are. Because let's say I want to create an empty JPEG file. So my picture.dpg. And as you can see here in my bash terminal, JPEGs and picture files are purple. And that should be for pretty much everyone else. That's how they show up. But this file, both of these files are the same file, you can say. They're both just empty files. But the extensions are different. So reality is the extensions kind of don't matter as long as you know what the file type is and use it in the right program. The file types are just kind of make things nice, but you should always make sure your files have different files. Usually text files on Linux, if it's just like a file with text, we'll just forego the .text extension. It will just be called whatever the file name is. That's how you usually see. Not all text files will have the extension .text. So yeah, but just an FYI on that. So now if I do ls, as you can see here, I see my different directories. I see my empty JPEG, and I see my text file. And these are all empty. But touch is really good for laying out a project. If you want to create like a bunch of code script or scripts or Python scripts or whatever, what have you, files, and you kind of want to lay out a directory structure, you can do that with touch real quick and create a bunch of empty files. Now let's just say, okay, well, I hate this file. I'm going to remove it. The command to remove a file is rm for remove. I'm going to remove my picture. So I do remove my picture, and this is permanent. There's no recycle bin here when you're using the command line. This, once you remove it, it's gone. So be careful with the command. Be very careful, because remove will this will destroy it. So just be careful when you use it. And now remove also has excuse me. We'll have different flags and stuff, which we'll get into in a second. But yeah, it's very simple. You remove a file. So let's just say I want to remove a directory. Let's try removing test2. It tells me cannot remove test directory. So as a safeguard, remove will actually not remove a directory unless you pass it a flag to say I want to remove directories. So the flag for remove is tick R, and then tick R is called recursive, which allows us to remove all of the files and folders recursively in a directory. So if I do remove test2, I can see it's been destroyed. Now, if I go ahead and let me create a file in test3, that will also get destroyed. So I'm going to do file1.txt. So now if I ls test3, I can see a file here. And if I remove that R test3, both the folder and the file was recursively deleted from the system. So now it's gone forever. So just be very careful. You may see jokes about doing remove-rf/, which will forcefully remove every full file in your system. So don't do that. But the F flag here, also you'll probably notice, but I did RF instead of doing R tick F. So both of these are synopsis. Some programs will allow you to combine multiple flags into one. So again, saving a key space, typing an extra space and a dash for each flag. But both of these are like the same thing. Or like when I did ls ASL, this is the same as tick S TSL. So Some programs allow you to do that. But RF is very dangerous, used very cautiously, because F will force. So it doesn't matter if the file's write protected or anything like that. It's just like, okay, I'm just deleting it. Goodbye. And I'll just destroy everything. So be very careful when you do RF. Sometimes you need to use it, but just be careful. You always want to triple check what you're removing here before you remove it. Because again, this is not a reversible operation without having to, like, you know, go use recovery tools on your hard drive to try to recover data. So all right, so that's copying, removing, making directory. Oh no, we got to copy and move files. Okay, so that's deleting a directory. Let's talk about copy and moving files. All right, so now we know how to delete, we know how to create directories, create files and stuff. Now we got to move stuff around. So I'm going to go ahead and clear real quick. So what do we got here? So we got my text file and test3. Okay, I want to move this text file into that directory. How am I going to move that? Well, of course, with the mv command. It stands for move. So the move allows us to move one file or folder to another file or folder. It actually also allows us to rename files. So let's say I want to remove my text file and I want to move it to my directory test3. As you can see, I'm using the tab auto completion. Save the day there. So I'm going to move this file. I'm going to move it into this directory and press enter. So now I can see the file is gone. And if I look in test3, the file is now there. Now, let's just say I want to move the file and also rename it. So I'm going to move test3, my text file. I'm going to move it back to my current directory. So, which I'm just going to type a new name for it. So I'm going to say my new text file .text. And I do enter. So this does the move operation to move one file from one place to another, but also moves it into a new name. So now if I do ls, I can see that this is the same text file as before, but now it's been moved and renamed into my new text file. So yeah, and you could also move, and also you don't have any special flags to move directories. So if I want to move test3, so say I want to move test3 and I just want to rename it, I'll rename it to test3 lowercase ls. So it's been moved from capital test3 to lowercase. Move doesn't require any type of like tick R or anything like that to move directories. It'll work with that as well. And so you can move things around. So if I make a directory test4, I want to move test3 into test4, I can do that. ls, as you can see here in test4, we have test3. And I can move test4, test3 back into here. So you can use dot. Sometimes you can use, so now I want to move it back to my current directory. You can see I'm going to use dot now. I don't want to rename test3, but I want to move it to my current directory. And if you remember what our current directory is, it's always dot. So I do that. And now it's back. Now it's back where it belongs. Actually, I'm not sure. I can't remember if it'll overwrite a file story there. Let me touch so I'm gonna move my text file into, I think it overwrites, yes. So be careful with moves because it will overwrite files if you move. So as you can see here, I moved my text file and I renamed it to overwrite.txt. So overwrite.txt just got annihilated. And now this has been deleted and it's been moved and it's replaced with my new text file renamed overwrite. So be careful with move. I don't think you can do the same thing with folders. Let me check. So I'm going to test3 to test4. Oh, well, duh. That's just going to move it inside. Okay.
Wait, I have a question.
Yeah, what's up?
So does the content of my new text file stay the same, just the name got changed and overwrite has been deleted?
Right. So let me go ahead and I'll show that real quick. Let me create a new file, my text file. We're going to talk about editing or adding text to files. So just ignore this real quick. So I'm going to just call this test. So now this, I know I'm going to be using some more commands I'm going to cover in like 10 minutes. So don't worry about this real quick. So as you can see here, I'm just showing that this file contains the word test. And then if I look at, let me add something to overwrite. And then, so now if I look at overwrite.txt, cat, this allows us to see the like what is in a file, which I'm going to go more in depth here in this sec. I can see it has test 34 and in my text file. So if I move my text file to overwrite, if I cat overwrite, you can see test 34 is deleted. It's now test. So it's replaced with my text file, and the overwrite is now destroyed. So this content and this data here is destroyed. So I know I just used like two new commands there, but we're actually going to talk about that. So don't worry about that. That's just showing that, yeah, that content does get destroyed. So it's like an overwrite. So like if you're on the Windows Explorer, it's like when you move a file with the same name, and it's like, do you want to overwrite this file? And you click overwrite, and it'll just delete the old file and replace it with a new file with the same name. So, but it doesn't have any prompts. And command line will sometimes hold in your hand, and also in some places and not hold in your hand in other. So let's be careful of, maybe just be mindful of that. So the commands will just do what you want them to do. So if you mess up as a human error, it's the command will just do it. And then you could delete a potentially useful file. So just be careful when you're doing destructive operations like move or remove. So, well, we can move. Well, what if I want to copy? Well, if you guessed it, copy is, oh, did I answer your question? You good?
Yes.
Great. All right. So now okay, I want to copy. All right, well, copy CP. So I can copy overwrite to new file of text. So now I could see if I actually look at new file real quick, I could see it's the same content as overwrite.txt. And cat here, which let me see when I get into the finding cat. Yeah, so we're gonna go into cat and stuff later, but cat, this will just print the output of a file. So yeah, so that just copies. If you want to copy a directory, like let's see what we got, test 4, test 5. Can't it will omit directories, so you need test 4. You need a flag, the tick R flag, for recursive remove directories. So same thing as like remove. You need a tick R to copy, and this will just copy the contents. Be careful when copying really large files, because this won't give like a status bar or anything like that. It'll just copy. So if you're copying a really large file, it may take a while just sitting here with no output until it copies. So there's other command line programs that'll actually give you like a progress bar when it moves files and stuff, but it's for another day. All right, so I think that covers all the other file commands. So we talked about removing, delete, removing files and directories, copying, moving, creating files. So all good with that. Okay. Very cool. All right, let's talk about wildcards and globbing. So let's just say I have some JPEG files. So I'm going to create some JPEGs. And you'll see me doing this with the up arrow, which I'm actually going to talk about in a bit. But turns out if you're in your terminal, if you tap the up arrow, you can see all the previous commands you ran. So really easy to do if you need to rerun a command again. Just hit the up arrow. So I'm going to go ahead and hit the up arrow. So I used the up arrow and went here and then I used my arrow keys to move over to test 3. And then I just hit the delete key to delete this and then put 4 there so I can quickly create some new files instead of having to type each one out. So now if I do here, I have a bunch of JPEG files now. And I'm like, okay, well, you know, I really hate JPEGs because, you know, PNGs are better. So I want to delete these all my JPEGs in the directory. But I'm like, okay, well, what if I have 50,000 JPEGs? Like, I don't want to have to go and delete each one. And now this is where wildcards and globbing comes in. So there's special characters that your terminal uses to signify different things. In this case, the star, or like the little multiply symbol, indicates what's called a wildcard or a glob. So the star means match anything to this that matches before or after. So that's what the star is saying, basically match everything, like find everything. So let's look at this command. I want to remove anything that matches .jpeg. So let's break down what this command is doing here. So what this is doing is this star means just pretty much match everything. Like I don't care if it's a file, folder, what have you, I'm gonna match it. But I add the .jpeg to it. So what this is saying, it's gonna find anything that starts with anything, it's gonna find, but it has to end in .jpeg, this extension. And so what this turns out happening is when I press enter and I do ls, it removed every single JPEG file, because it doesn't matter if it was what the name was of the file was, since it matched, because this matches everything. As long as it was a .jpeg file, it was annihilated. And so that allows us here to quickly find, remove, and you can do this with anything. Like it's not just removing, copy multiple files, things like that, using wildcards to move batches and a bunch of files or copy them.
I got a quick question.
Yeah.
If you had done rm test star, would that have done the same thing? Or am I understanding this wrong? Yes,
that would do the same thing, but it would also try to remove these directories too. So you got to be careful when you're globbing. You want to make sure you're removing the right files. Because again, if I do test, so let's see, let me touch a JPEG again. So if I do remove test star, as you could see here, it was sad for removing the directory, but it actually did remove the JPEG file properly, but it gave us 2 errors on removing the directories. If I did remove tick R, test star, that will actually remove all the directories that match test star. So this is also very powerful and also very dangerous, as you can see. So you want to be careful with your glob that you don't delete these commands. So you want to make sure you don't accidentally match other things. So let me go ahead and create some of those JPEG files again. And I'm going to also make directory test directory. So
Brandon.
Yeah.
Oh wait, no, sorry.
Good.
Yeah, I figured it out.
All right. So I am going to, let's say, okay, I want to remove my JPEG files that start with test and end with JPEG. I don't care what number they are. So I can do remove test. They start with test. I want to match anything between test and JPEG. So now what this is going to do, it's going to remove anything that starts with text, has infinite amount of random characters in between, and ends with JPEG. So if I do that, this will be nice and neat, where I only deleted my test JPEGs and test directory. As you see, since I never got this error, that it didn't try to delete test directory. We were good to go on that. And you can do the same thing with copying. So as you see here, I have test2. I can do copy test2 test star.jpg. I want to put it, now I want the output directory. I'm going to output it into test directory like that. And if I do ls test directory, I could see those same exact files here that are also here. So globbing works with any program, anything. You don't have to glob just directories and stuff too. You can use like for different strings and stuff, but typically you're globbing, the wildcards and globbing are using for files and directories and stuff. But you can use it, but I don't know if it has the same name in regex. I think it works the same way in regex, but don't use regex. It's scary. I don't even use regex, but yeah.
Isn't it clean star in regex?
I really don't know. I haven't. It's been a hot minute since I used regex, but usually star is synopsis to a wildcard and a lot of different things. So, or called star, call it the multiply symbol. No one, I don't know. What is it? Asterisk. I think I said that right. Asterisk. But yeah, but that's globbing. There's also a bunch, there's also other different globbing and special characters, but we're not going to get into that. Really, star is kind of a pretty basic one that you'll be using a lot, but there's different other ones that you can look up to do different things. Like I think there's one to match a single character, which I think is question mark. I'm not, don't quote me on that, but there's different globbing techniques and stuff that you can do. But star is usually kind of easy, like what you use. But all right, let's talk about finding files. So now, obviously, you might have a lot of folders and files in your system. You might need to find some stuff from the command line. So luckily, there's a command called find. So the find command is kind of, it's a command. It has some different syntax and stuff that is different from what we've seen before and different from a lot of programs. It's a little bit wonky. So just bear with me here. So if I have some files here, I want to find something. I want to find it in this directory. So I put the directory first, and I wanted to give an argument. So name. So this is an argument here of name, and I want to find new file.txt. Well, turns out it's right there. It found it for me. So it found it here. So in this case, find is the command. This dot is the argument indicating the directory, and then name is a flag which takes a value, the name of the file we're looking for.
Real quick question: the directory, if that wasn't specified, would that throw an error, or would it just search everything?
I'm pretty sure it'll throw an error, but we could always trial an error. No, it'll just find it starting from this directory, so it will not throw an error.
Good question.
Go ahead.
Will this search any subfolders as well? Like if our new file.txt was in testdir, would it find it there as well?
Yes, I think so. I think it's automatically recursive, but like I said, we could test. So let me do
yeah, I mean, I was gonna say, what's the use of it if we can tab autocomplete and check if the
well, yeah, I mean, yeah, that would make sense. Let me, oops, new file text. Let's see. Yep. Yeah, so I didn't know if there was a flag to do it recursively or not, but that makes sense. Yeah, obviously it's always recursive, but yeah, so it's recursively, it'll find the files and stuff. You can also use glob and stuff to do this as well. It'll take in glob. There's a bunch of other different arguments for find, which honestly I don't use find that often because it's kind of a pain to use, but it's a very powerful command to learn how to use. So let's just say if I have, so you see I can do new file. I can also do globbing. So I want to find all my text files. It made me angry. Pass must receive expression overwrite.txt. As name, I think I had to, does it not like it? Okay, yeah, it didn't like having a wildcard in the beginning. So as you can see here, it got angry on that. So let's say, what do I have? So let's just do find new. I think that should work. Yeah. So I want to find a name new and then star and then .txt. So here it seems it doesn't like it using glob at the beginning. I'm sure there's a way to change that, but like I said, I'm actually kind of unfamiliar with find because I don't use it that often. But find will allow you to just find files, and the very simple use cases is using like the tick name.
Quick question again.
Yeah.
From one of my classes a long time ago, one of my professors mentioned that there was a better method for doing searches.
Yes.
Have you heard of it?
Yes, it's locate.
Oh, okay.
Let's talk about it. Yes. So that's the find command. So like I said, find is kind of cringe, and so it's kind of annoying to use. It's very powerful. It's pretty much on every system, so I recommend learning it. You know, a lot of veteran people, Linux users and stuff, probably don't know how to use find too. So it's, you know, it's kind of an odd state, but yeah, it's a lot of syntax to learn and stuff, but very powerful, very easy, or not very easy to use, but it's useful. But there's another command called locate. This program comes default in Linux, or Ubuntu, like Debian Linux distributions. typically, but it's not really, it's not universal in any way. You have to install it and set it up and stuff. But there's a command called locate. So locate, this does it really easy. You'll just locate. As you can see here, I just did locate and the word test. And now anything in my file system with the word test in it, obviously it's a lot of files here, so you can see. So let's go ahead. I'm going to clear that out. But the locate command allows you to locate files. So I'm going to locate. Oh, should probably spell that right. So I did overwrite.test. So I just did locate overwrite, and it gave me a bunch of stuff here that it looked for. But locate also kind of had own issues. So you can see here, I don't think it found my overwrite.txt. Wonder if it did. Damn, it's right there. Oh no, did I delete it? No. Wow, that's a sad command. See, the thing is what locate is, it has to actually index the files. It's like Windows Explorer. Like if you try to search for something, it's just like, hang on, while I spend 30 years indexing your files. Like that's actually what locate does. It has to index your files. So stuff that you create may not be available right away when you locate and stuff like that. Depending on how the system's set up. I don't know how it's set up on Newton, but I think it indexes pretty quickly if you install it locally. To index those files, but it has like its own database and then indexes and searches a database to find things faster, while the find command will actually look through the directory itself. It doesn't have any database or anything. But it is easier to use because you don't need any type of, like flags and arguments. You locate whatever you want to locate and it'll find it for you. So it'll find year matches to the exact thing. So yeah, so it's kind of like the search in like a file explorer, but it's not that universal compared to find. So find, if you learn how to use find, you can use it anywhere, pretty much on any type of Linux, Unix, Mac OS system. All right, so that's finding files. But okay, so I just told you to like, okay, well, you need to learn more about the command. And you're like, well, Brandon, where do I go to learn more about commands? Obviously, I would just say Google it, but turns out you don't actually have to Google it. So there's a command in pretty much most distributions called man, and it stands for manual. So pretty much every program has a manual to it. So if I do man and I want to type the program I want to learn more about, I want the manual for the program find. It's going to give this whole thing, this whole scrollable huge text wall of documentation. And this is the manual for how to use the find command. This is built-in documentation. So on any system, if you did man find, you should, as long as the program exists, you should see the manual for it. So it explains how the description, the usage, like how to use it. It explains what each of the flags do, what the arguments do, how, sometimes they'll provide some examples, like example usage. As you can see, the find command has a lot of information, and I'm using my scroll wheel for this. You can use your arrow keys, or you can use page up and page down to go quicker, or you can use your scroll wheel. As you can see at the bottom here, you can press H for help or Q to quit. So you can just press Q and we'll just exit out of the program. I'm going to go ahead and go back in here. So you can do this for every any program pretty much. And so if I want to learn more, I'm like, okay, how does ls work? Well, I'm going to do man ls list directory contents. Wow, thank you. And then you could see the tick A or all, do not ignore entry starting. You can see some of the flags that we used. So we saw A, we saw, what was it, L, use a long listing format, which puts it in that like list. So yeah. So if you ever want to learn anything, man, whatever you want to learn about, and you'll learn about it. So I wonder if there's man. So man Python. So I'm going to learn more about the Python program, which is an interpreted interactive object-oriented programming language. And it's going to tell me all about Python and how I can use the command line. So man is your friend. Take that as you will. Yeah, so that's stands for manual, allow you to learn about all this stuff. So let's see, I got 15 minutes. Oh, I still got some stuff. Now I'm gonna need more time. All right, let's try to get through the rest of this. So we define learning more about the command. So let's talk about downloading files and stuff. So there's some web-based commands that allow you to access the internet and do different things. So we want to download a file. There's usually two programs we can use typically, which is curl and wget. So curl, wget is more for like getting files or downloading files, while curl is pretty much, you can send any type of HTTP request with curl. So it's a little bit more robust and it can do a lot of different things compared to wget. But let's go ahead and download a file here. So I'm gonna go ahead, I'm gonna download this file from this website here. Hopefully this website is still active. But here's the link here. I'm going to do curl and I want to put it in some output file. So this is, I think, for some book, the VSCs, yeah. And then I'm going to copy this. I copy this link. I'm going to paste it here. Hopefully it's still there. Let me just make sure. Is it not there anymore? I mean, let me click the link to make sure. Oh no, the example broke. Oh no, it's still there. Okay, good. So does this not work now? Can you download, please? Okay. Well, apparently it doesn't like that. That's odd. That the tick O allows us to specify the output command, and then this is the web interface. I wonder if Newton can't access the file. Oops. And sorry about that. Technical difficulties. Oh, that worked. Okay. I guess curl was angry. Am I missing something here? Oh no, I named it to page 430. Okay, there we go. So this is the file I downloaded here. So curl allows you to do some different requests and stuff like that. And wget just downloads a file. And so it automatically named it to this. You can also do tick O to rename it. So if I download this and I have a tick capital O this time, lowercase, I'm gonna name this Ulysses.txt. Looks like
Curl works for me.
Girl. I think I was just overlooking the file. Okay, yeah, I'm just, sometimes I do that. But I go ahead and download it, and so this is a file I downloaded again. So I downloaded the same file, but I renamed it to Ulysses.txt, which is here. So there you go. You can do curl with this and wget. So wget, normally you use this to download a file. That's what it's mainly used for. And curl, you can do a lot of cool things with doing specific requests. Like if you're trying to do like some type of web API or something like that, you can use curl to like automatically access it and do some things, or download JSON files and or parse them and stuff like that. So it's pretty cool. So that's for downloading a file. So now that we have this book, I'll talk a little bit more about cat and outputting stuff. So let's ls. So we have this Ulysses text file here. Cat, if we look at the man page, we can actually do that real quick. Cat concatenate files and print it on standard output. So it takes some file and print it to your screen. So we're going to do cat Ulysses.txt. It's going to give us a bunch of, well, buddy, dude, this doesn't look like text. Okay, well, it just got angry at me. I don't know why it's angry. The heck? Dude, not liking me today. Well, cat, so as you can see there, it's not a text file, and so it got mad. But it'll print any file. So if it's just like a binary file, it'll actually print like the binary contents to your screen, like try to interpret it as text. So you'll get some weird stuff like that. But if I cat like the files I created before, as you can see here, these files have the word test in it. I'm not sure what happened with Ulysses. He got destroyed or something. But anyways, I don't have time to mess with that right now, so we'll just move on. But that's just how you download stuff. There is also some other type of cat commands that, as you can see here, if you have a file that's really large, it's going to print the whole thing, and that you may not want that. So there's also a command called less, which allows us to view things in pages. So actually, maybe a binary file. Yeah. So if you do less, you can actually look at a file in like a page format. So in this case, this is a short file, so it's just an N. But it allows you to have like in the manual page, like where you can scroll up and down through it and stuff like that. It allows you to scroll through that through a file and not just print it all, just dump everything to screen. Yeah. So that's the less command. Oh, excuse me. For that, and less works with any type of, and this is not just for text files. You can do this with any file. So if you have your code, like Python files, you have YAML files, you got CSV files, JSON files, you can print all of that to output. You can look at it. You can use less to like scroll through it. You can use cat to cat it out. You can do all that stuff.
So when you say you could do cat to cat it out, would you do like less and then cat and then the two
No.
files or whatever?
No, you can just do less. So you do less and then the file name. So in this case, like I did that. So that's it. So this will use the less program to do it. And you
Okay,
can press
what if
Q
you
to do
wanted?
it.
What if you wanted to look at like two files, like overwrite and the other one?
Well, you can actually do some piping, which I was just about to get into, but you would basically cat, you can actually cat two files. So if I provide these two, it'll actually cat both files separately and print them. Now, there's a thing called piping and stuff, which I'll get into. I'll get back to you just in a second. Let me finish up this stuff. But there is a way you can do that. So let me, yeah, we're just about to get into that. So that's the cat or less commands we use to view the contents of the files, useful for debugging. Like if you have some text output, like a bunch of files, you could use less to scroll through it and stuff like that. You can use cat to just dump it to the screen if you need to. So yeah, it's useful there. Now, what about searching files? So grep is a very common program you're going to see in a lot of tutorials and used for a lot of different things. So let me, it's annoying I couldn't download that file, but grep allows you to search files for different strings or search some type of, not even just files, it can search any type of strings or text for whatever you want. So let's say if I want to grep and I want to find the word test in my overwrite.txt. As you can see, you can find it there. So let me actually, I'm going to look at overwrite. I'm going to add some words. Okay, just add something right there. So I can look at that. So if I do that again, you can see I found test and I found test, matched it and 3. So I was able to match that. There's also different arguments it can take. So the grep command takes 2 arguments. It takes the text you want to search and then where you want to search it and the file that you want to search for. And it searches it by line. So if I want to say, hey, I want to know the amount of occurrences, I can do grep c test and I can do overwrite.txt. And you can see test occurred 2 times in this file, as we confirmed right here.
Wait, how was it that you exited the screen where you were writing to the file?
Oh, sorry about that. Yeah, I'm going a little bit ahead of myself. So nano is a command is a command line text editor that allows you to edit text in the command line. So I'm going to edit this file. So it allows me to scroll through with the arrow keys and type and stuff like that. In order to exit and save the file, there's some help down here and it tells you. So exit, the little caret is control. So I'm gonna do control X. It's gonna ask, do I want to save the file? I'm gonna type Y. And then it's gonna want to know the file name to write to it, which in this case, I wanna keep the same file name because I wanna update the file. I'm gonna press enter. So that's going to change the file. Sorry if I'm rushing towards the end here. I want to make sure I get through this. But
Brendan, I totally made a mistake.
Okay.
You actually have till 12 today. And then the next time's 1 hour. So I'm so sorry.
All right, we're done rushing. All right, well, let's slow down here then. All right. So since I have that time, let me go and actually see why this file is not downloading just for 1 second. There might be this, sometimes it's something dumb to miss. If you click it, it comes out properly. I don't know why it wants to be a binary file. So there's another command. Well, we can learn some stuff for this. Sometimes you gotta learn from, when stuff breaks. So there's a command called file that will actually tell you to give you information on files. So I want to look at this file. So as you can see here, when I did file, it told me it looks like it's compressed data, which is really weird. Okay. So you can learn, so you can learn a little bit more about files that like, okay, this should be a text file, but obviously it's not a text file. What the heck is this file? So you can use the file command and it'll give you information and pass it some file and it'll give you information on that file. It'll try to figure out what it is by reading it, like the headers and stuff, and figure it out. So now I've ran into an issue. I'm first going to see, okay, what this file is, and I see that's DSIP. So I'm actually curious if this would work. Let me try something real quick. Oh, whoops. And so I'm going to move it to a DC. I'm going to see if it actually decompress. Yeah, okay. Well, I guess we'll learn it. So the more you know. So it looks like it downloaded. Did everyone else like have this issue? If you did file in your Ulysses that you downloaded, did it say it was a DSIP format? Curious that happened. Or if you cat it, you should now see the Ulysses file. So if for the people that downloaded it, if you did, so let me go through this process here real quick. So I want to download this file. I'm not sure why it's compressed, downloading and compressed. That's really odd because we're supposed to be downloading a text file here. But I'm going to do, I want to download as ulysses.txt, or when we do download, I'm going to download as ulysses.dc, which is for the gzip file. So let's give it a second and download it again. So now that I have this Ulysses, let me make sure it's still a gzip file. Okay. So now gzip is just a way to compress a file. It's just like another compression scheme. So if you want to follow along, so we all have this text file to work with. I'm going to do gzip, which is another program to do decompression and compression of files. Tick D. So this is a flag stating I want to decompress. And then I want to decompress the file I just downloaded, ulysses.dz. I already created, so I'm going to overwrite it, but yeah. And then now you should just have the file called Ulysses that actually is the book and properly done. Does everyone have the file? Let me know if you have any issues with doing that commands.
Can you demonstrate curl one more time?
Curl, yeah, I can just hit up arrow 30 times and I can show you. There. So this is curl. So curl tick O for output. Ulysses, this should be .zz. So let's do DZ. And then we're going to download this. And then now if I do file, yeah, curl doesn't like me for some reason, but hopefully it likes you. And all right, does everyone have the file downloaded and decompressed? You know, it's funny. I think this happened in the last tutorial too, and I may have never updated this with this file. Now I'm thinking,
It did.
Mine's doing the same thing as yours.
The exact same thing with the Ulysses file.
You know, maybe this is part of the tutorial now because it gets like, okay, you run into an error, work through it.
Look, you've covered since this. You've covered gzip. You've covered, you know what I mean? So
it works out. Okay. All right. You know, we'll leave it as a surprise every year for me to run into this issue.
On bug, it's a it's not a bug, it's a feature.
Right, exactly. If you're having trouble with curl, just use wget.
Quick question.
Yeah.
So wget deletes the original compressed file, it looks like.
No, wget just downloads the file.
I mean, not wget, gzip.
gzip. Yeah, well, it doesn't delete it. It decompresses it, and then it will remove the compressed version. Right.
Okay, that's what I meant. Okay, cool.
Yeah. So now everyone should have a file that's called Ulysses. Everyone good with that? Yep. Okay. All right, so now that we have a nice text file, we can actually see some of the features more in action here. So let's look at, so if we cat Ulysses, we could see that we just get a dump of the entire book. And it's like, okay, well, this is kind of, I don't have to scroll up and figure this out here. So less is more. We're going to do less is Ulysses. And now we have a nice little page here that we can scroll through. We can come up. We can use the page up and down again, like we used before, or the arrow keys to go line by line, or the scroll wheel. And now we have a very more digestible format for looking through this file using less. Yeah. And then if I want to quit, I just type Q and I quit. So that's the cat and the less. And then we can also grep some files and we can kind of look through this file a little bit more. I'm going to grep the word stately in the Ulysses file. So as you can see here, I found two instances of the word. Oh, excuse me. As you can see here, it does not print just the word, it prints the entire line it found. So this is the line, or this is everything after when it found a word, this is what it had for this line. And then this is this line as well. So this is like, you know, one line of text and then a new line character. It prints that whole line. And again, we could see some different counts. So I'm going to do the C again. I want to see how many times this word appears in Ulysses, 64 times. So this word appears 64 times in this document. Also, by the way, your text searches, you can't use glob syntax. Like I can't just do like grep C lovely, like, or just like love star. Oh, I guess you could. Depends on what you're doing. Let me see actually how it works. I think it uses regex. Oh, okay, so it can. Oh no, I don't think it's just working for the word love. I don't think it's actually registering the star. Well, maybe it is. All right, I'll take that back. You can use regex if for anyone familiar with that though. Grep will accept regex stuff and things like that. And I think this is actually using like a regular expression. And I think the star just works the same. But yeah, you can use regex to find stuff, and you can also use star to search multiple files here. So like, oops. So let's see, I had the new file no overwrite. So if I want to do, I can grep test and I can do star.text. So it's going to search for every text file in here. It'll actually show, okay, a new file, it found this, and overwrite that file, it found this, and overwrite, it also found this. So you can search multiple files. So, and I use the wildcard for globbing that. So you can search, so you can combine all the, everything, all these little things I'm teaching together can all be combined together to create some powerful command line commands to do things like this. You know, I could do tick C. So if I do tick C, it found the test one time in new file, 2 times in overwrite. Page 430, it found 0. So as you can see here, you're like, okay, well, Ulysses is a text file. Why isn't it searching it? Well, it's because it doesn't have the .text extension. I'm only looking for star.text. I can actually just do .star, which grep doesn't like the test directory, but it'll also find in all the other ones. So I tried finding it in the JPEG files, found test in Ulysses 96 times. So yeah. All right, so we did some searching. Let's search for things like, okay, well, what if I want to search for something that is multiple words? Well, you can't do lovely. So say I want to search for lovely socks and I want to look in Ulysses. As you can see here, you're like, oh, I found lovely, as you can see here. And it's trying to say grep socks, no such file directory. You're like, okay, well, that's not what I was looking for, because it interpreted this as a file. Because your first argument is what you're looking for. So if we want to fix this command, we would need to use quotes to quote around the string we want to search for. So I want to search for the string lovely socks using quotes, and I'm going to look in Ulysses. And as you can see here, we found it in one line right here. So it worked properly. So it's good to get into the habit of quoting your, if an argument has spaces in it, you're going to want to put quotes around it. Get in the habit of doing that. Important. Any questions on any of that? Good. All right, cool. Search for more. All right, so now we're going to talk about the power of redirections and piping. So, and we'll also get back to your question, Michael, about how can we like, I kind of answered it with grepping for multiple things, but we can look at a different way. We want to cat multiple outputs and search them. So we're going to look at that with piping. But first, let's talk about redirection. So now that we've kind of went through this whole tutorial, we're going to talk a little bit about some basic concepts with the command line. So we have a thing called standard in and standard out, or STD in, STD out. And I'm sure all of you have some programming experience, so you might have heard of standard in and standard out. As standard in is standard input. It's how you input into the command. It's the buffer that's used to input into the terminal program, and then standard out is what is for output. So in the simple case that we've been using it, standard out is what we have been seeing being printed to the console here. This is printed to standard out. You also have some other inputs. So you might have heard of standard error, which is a different thing, which is a different buffer that is used to print errors to. And usually you'll see standard error and standard out printed to your terminal, but you can actually redirect standard error to one file and standard out to other files, or redirect different things. So you can actually redirect different outputs into separately, like for error, standard error and standard output. So let's go ahead and look at how this redirection can work. So let's say I did this grep of, let's go back to the stately when I looked up the word stately. I'm going to grep stately. So now it printed some output, and I'm like, okay, well, that's cool. I like this output and standard out, but what if I want to put this into a file? So I want to save my search results to a file. I don't want to have to copy this, use nano, open up the file, copy, paste it in and stuff like that. I can actually redirect it. So let's look at this. So I'm going to run this command again. I'm going to hit the up arrow again to bring up the command, and I want to do some file redirection. So I want to redirect standard out to a file. So I'm going to use what's called, I'm going to use this little arrow, this little, or greater than or less than sign, whatever you want to call it. And this is for doing redirection, for the redirect. You know what? I don't have to redirect this in a file. I can redirect this into another buffer, like standard in or standard error or stuff like that. But for now, we're just going to worry about some simple redirection with file. This redirection is very powerful. You can add in like a bunch of arguments to like redirect like standard error to one file, standard output to another file, do some crazy stuff with that, but we're just going to keep it simple. So I'm going to redirect the standard output of this command into my some type of results file. I'm going to call it results.txt. When I press enter, as you can see, nothing printed. And you're like, oh, well, the command did not work. It did work. But now if we use cat to look at a results file, we can see that this is the output that we saw here. It's been redirected into this text file that we can now use, that now exists here, right here. So now do we save the results to a file? Now, if we run this command again, it's actually going to overwrite the file. So let's just say I want to, I'm going to hit the up arrow a few times here. I'm going to use my arrow keys to move over. I'm going to delete, oh, no, I still want that. I want to delete the search. I want to search for lovely. Enter. So now we do the results. If I cat results, as you can see, was a lot of results in here. But as you can see, my original 2 lines here with stately have been destroyed. They're not here anymore. And we can confirm that if I hit the up arrow again, I'm going to run the command where I grep stately here. And I'm going to clear, just to clear all that out. And then I'm going to cat, or I'm going to ls, just to see what I have. I'm going to cat results, hitting tab to autocomplete there. As you can see here, that has been overwritten. Now, what if I want to append? So to append, I can use grep. Well, I'm going to search for the same thing again in Ulysses, but I'm going to use 2 arrows. So 2 arrows is for appending. So 1 arrow is to just output it and save it to a file, overwriting whatever is there. While this will create the file if it doesn't exist and add it. But if the file already exists, it's going to append it. So I'm going to do results.txt like that and press enter. And if I cat results, I can see it did the same search twice. It appended and saved the original contents have been saved, appending to its contents. So in this to show here that if the file did not exist originally, so I'm going to do search on some text and cat search, I could see that it just created the file. So this 2 arrows will create the file if it doesn't exist, but if it does exist, don't overwrite it, append to it. And that's some pretty simple redirection. Now, there's also tons of other redirection you can do. You can also redirect the other way, where you take input from a file using this operator and actually use it to run, like put it into a program and stuff. So you can redirect standard out to the file, and you can also redirect file to standard out and do some cool stuff like that. But for the sake of time, we're gonna gloss over that. But just to know that what I'm teaching you here with redirection and stuff is just the tip of the iceberg. You can do a lot with this stuff, and it's really cool. So now that we know how to redirect some files, let's talk about pipes. So you might have heard of pipes before. You know, they're in your house, they move water around and stuff. But for Linux here, kind of actually works the same way. We can actually pipe output or input from different files and pipe them, connect them into another program to use that output. And the pipe symbol, if you do shift / will give you the pipe. So it's this bar here. So that's a pipe. So now let's just say, okay, I want to grep standard output. So say some program outputs some text. I want to actually take that text, pipe it into grep, and look for something in it. So let's try this. So I'm going to redirect standard out into standard in for another program. So I'm going to cat Ulysses, which we know will print the whole Ulysses thing. I'm going to pipe it into the standard input for this command, grep, and I want to grep, we'll do stately again. Now, when I press enter, I actually get the same output of just grepping it from the file as I did before. Now, as you can see here, what this did was this did the cat, which we didn't see in standard output because we didn't see it because before it got printed out to the screen, we piped that, we connected that into this program and passed it in as standard in. So like I said before, grep can actually not only search files, it can just search raw text. Like I can just pipe, like the text can come from anywhere. It doesn't have to be saved on a file on your computer. It could be in the buffer, it could be piped in, it could be literally anywhere. And grep will search it. And so what I did was practically the same. It got the same result, but I did it in a different way by piping output from a command. So now this is more useful. Obviously, grep can already search the file, it's there. But say if you have a Python program that has output and you don't care about that output, but you want to look through that output, you can run the Python program, grep it, and pipe it into grep and look for certain things. You don't have to worry about saving the text first or saving the output of the program to the file and then searching that file or stuff like that. It'll just do it all in one go. So that's what pipe does. And you can chain pipes together. So let's go ahead. Let's go ahead and do some cool stuff. So I'm going to cat this again. I'm going to pipe this to grep the word father. And then the output of that, because we know this actually is output stuff to standard out again, I'm going to pipe that I'm going to pipe that results into another grep for mother. And you should see this. So as you can see here, we saw the output of father, so we see the word father in here, and that further was search for the word mother. So, and you can do infinite pipes, you can pipe a bunch of different stuff. So this just allows you to chain programs and stuff together. So you can you could do parsing stuff really easy, and grepping and stuff like that. Because there's actually some shell scripts and stuff that can actually take a string and modify it and then print that out, and then I'll get piped into another program, I'll get piped in another program, and I'll do some cool stuff. So it just, you can go on and do a lot of stuff with that. But the very basics of pipe is you pipe one output, or you pipe one buffer, one file, one output of a program, and pipe it into another program, put it into another program. So it connects a pipe from standard out to standard in, something like that. So this, like I said, I'm just using grep and text files just as an example, but this works for any program. Like, for example, let's say I want to do ls. I want to pipe the output of this into grep, and I want to search for the word results right there. So ls, I know, prints this. I pipe, instead of printing it out, I pipe this output into the grep program, and I was looking for results. So basically what happened here is it's like I typed grep results here. I ran this, like I'm running this program, but instead of providing a file, I instead piped the output of this text as my argument of what I want to search. And that's what happened. And my result is I found the file results.txt. Any questions on piping and read or file and folder redirection? Good. All right. Like I said, this stuff's the tip of the iceberg. There's a lot more you can do with this stuff, but just, I don't want to overload you guys, and for the sake of time as well. But just know that there's a lot more you can do with this. I also talked about some other shortcuts. So I already mentioned that, like, you can press up arrow and search through up and down arrow, and you can search through your bash history, or command history as it's called. So you can run commands again. You'll see sometimes people are like, oh, I ran this command 30 years ago. Instead of typing it, I'm going to hold up arrow and look for it for 20 minutes. So don't do that. I do that sometimes. Everyone does it. Just don't do that. You know, if it's that far up, just type it again. You'll waste more time hitting up arrow and trying to look for it. But yeah.
Isn't there like a bash history file where we can find all of the commands or something?
Yes, there is. So I'm going to ls tick a, and that's the file we got. There's our bash history.
Okay.
That's your file. It's different for different shells and stuff like that. Like I said, there's different. Bash is not the only shell and stuff, and I know these words kind of don't mean anything, but they may not mean the same. They seem like they mean the same thing, but they don't. But typically you'll have pretty much every system has bash or uses bash. So you'll find a bash history, bash RC, which configures it stuff, and this is in your home directory. So but yeah, you can look through that as well. And that's just a text file, so you can just look through it and grep it and look through it as well using the methods we used already. So there's also some other shortcuts. Let me clear this out. Oh yeah, reverse search mode. I'm sorry. So I don't actually use this as much. So if you do Control R, you can reverse search your history instead of just typing IPOwer 1,000 times. So let's do cat. So as you can see here, I'm searching my bash history for something. So when I search for the word cat, I could see the last program I ran. So that's Control R, reverse search. What's a command that I didn't run for a while? Maybe CD. So I did CD test a while ago. I don't know when I did that, but CD. So I think you can see there, that's the command I ran. Obviously, I'm already in there. So I don't know such file directory, but that's a reverse search, and that can help you with some of the stuff. Personally, I actually don't use reverse search that often. But you can, if you know that, if you kind of remember what the command was, you can use that to quickly find it, even if you didn't run it that far ago. So you're not pressing up arrow for 20 minutes. So you can also use grep on your bash history too. So I mean, that works too. Might be a little bit more tedious to do that, but yeah, Control R for reverse search. All right, so editing text files. So we already kind of looked at that with Nano, but let me formally go over it real quick. So Nano is pretty much almost on every system. It's a command line text editor, very easy to use. You know, it has all the stuff at the bottom. You could do Control X to exit. You could do, so I'm gonna open up the Ulysses text using Nano. I think it's Control W to search for something. So I actually found the first occurrence, so Control W to search. These little carrots remember control, so you can actually use this stuff. I recommend using Vim. Vim is kind of hard to use at the beginning, but Vim is another command line thing that is, it's all keyboard shortcuts. There's no mouse and stuff like that. You have to like press I to like insert and things, and it's like, it's a little difficult, but mastering Vim allows you to pretty much type very quickly because it's all keyboard shortcuts. So if you can memorize all the keyboard shortcuts for Vim, you can type really fast and edit files real fast. In your free time, you can type the as long as you have Vim installed, you can do Vim Tutor, this program, and I'll actually teach you how to use Vim. So built right into the command line. So you can go through that, and you can read all this and I'll tell you how to use it. So it's up to you. It's really personal preference. But typically Nano is really easy to use and get the hang of. So I recommend starting with Nano, and then once you're comfortable with that, use Vim. So you remember when you're editing in these text editors, your file doesn't save automatically. So if I Nano Ulysses, like I have to do, and I make some changes, I'm just gonna type some stuff here. When I do Control X, I have to save it. So like say if my program crashes or something else happens, or my connection is lost to Newton, this file does not get saved. There's some auto recovery options built in, and it'll ask you if you want to recover this file and stuff like that if you try to edit it again, but it doesn't save until you save it. So as you can see here, when I do Control X, I want to save, say, no, I don't want to save. So I'm gonna press N, so it just X's out of it. And then if I run Nano again, I could see that my edits here were not saved. So just remember that. That's pretty much it. I mean, it's just really learning to use Nano. Nano is real simple to use. I mean, really, you just type, you can search, Control X, Y to save, and then you can rename the file if you want to save it as a different file. So let's say if I do some edits here, I do Control X, I'm gonna hit Y, I do want to save it. I want to name this to Ulysses 2. Say, ask me to save my file under a different name. I'm gonna type yes. So now I have Ulysses 2. That's my edits.
How did you exit Vim?
Vim? Yeah, it's a common problem to learn how to use Vim. So Vim, when you use Vim, you're gonna hold Shift and a colon, which allows you to run a command in Vim. You're gonna type Q for quit and then press enter. Yeah, that's sorry, that's just like, it's like a Vim kind of has a pretty big meme tied to it. With just because people, there's like the Vim master race, quote unquote, because people are like, yeah, Vim is the best, Nano sucks, everything else sucks. And there's whole debates about which text editor, command line text editor is like the best thing. So it's really comes down to personal preference, but Vim and Nano are pretty much what you'll see. You also see Emacs, I think it's called, which I don't know if anyone actually uses that, but yeah, it's just people that use that. So, but Vim and Nano are pretty much your common go-tos for text editing in the command line. So in my little tutorial, I have a section about calling root. So I'm just talk a little bit at you because we can't, Newton doesn't allow us to run commands as root. So every Linux system or Unix system has a user called root, and the root user is pretty much like the super admin user. Like you can modify any file, you can delete any file in your system. It's not like Windows where if you try to go delete a protected file, it's like, sorry, you can't delete it. It's like, well, I own this computer, like, please let me delete it. It's like, no. In Linux, you can delete any file, even if it's really important to you, critical to your system running, as the root user, or running a program as root. So you have to be very careful with that. But root is it's on every Unix system. There's always a user called root, and the root user has full access to everything. There's no permission that can stop the root user. It has full access to every file on the computer. Obviously, for obvious reasons, that's very dangerous. So, you know, if you might see like a hacker, they got root access. That's kind of what they mean. They're able to get root and get permissions to everything. So there's nothing stopping them. They have full access. So that's something to talk about. We can't do that on Newton, but if you have your own Linux system, you can, or which I highly recommend getting, you can mess around with root. In those programs, a thing called Sudo, which allows you to run a single program as root user. So it's like you're running it as a root user, but you're not logged in as the root user. So it allows you to be more safe about running commands as root. On your personal systems, Linux systems and stuff, you'll have access to sudo. Here, we can't do that. We don't have super user access. They'll get angry if we use that, so we can't do that. All right. Wow, so that covered a lot. So in the last few minutes, we're going to talk about shell scripts. So let me talk at you a bit more. So bash was mentioned in the beginning. So we talked about that, like bash, shell, like what are these things? So a shell is the interpreter for command line instructions. So it's a very broad overview. It's overview of a shell interprets command line instructions as we type here. It's very similar to how the Python interpreter works. It reads your files line by line and interprets that. Because Python is a scripting language, and so is shell. So they actually are you can use them quite similarly because they're both scripting languages. And you can run full programs just in shell code alone. So then I mentioned bash. So what is bash? So bash is a type of shell that gives you a lot of benefits. So if you use shell on its own, there's a lot of, you can't tab complete, you can't do a lot of things. It's very basic, bare bones. Bash adds a lot of utility to your command line, which is what here, our command line. Bash adds a lot of utility that allows for more customization, like making our prompt look pretty and stuff like that. And tab complete and other quality of life features. You can kind of think of it as like an IDE for a shell, like some type of like overlay or something. It's not really like that, but it builds upon the standard shell to give you a lot more features, quality of life features, you know, making things like look cool and color coded and all that stuff. Because like all this color coding, this happens here, this is all done using bash, and it'll automatically do that. And if we looked at when we did the ls of our home directory, we could see that there's a bash RC file, and this actually configures bash to like make everything look pretty and stuff like that. So now all the commands that we've been running one by one, we can actually put into a script to run them automatically on a script. And these are called shell scripts or just scripts. So let's go over a very simple shell script example. So let's use our nano, and we're going to create a thing called, my first script. Now, script files have the .sh extension. They don't have to have it. Like I said before, it's just to signify that they're a script file. So, but yeah. So let's start with a script. So your scripts are going to, at the beginning of every shell script file, you need to define what shell you want to use. So the shell I want to use is bash. So this is a syntax for that. This pound sign, exclamation point, bin bash, and this is the first line of the file, signifies I want to run this script with the bash shell. And you can actually do bin.sh. So every single Unix system in existence always may not have bash, but every single Unix system in existence has shell, which is bin.sh. Everything has a shell. And the shell doesn't have a lot of the features and stuff that we want, but pretty much every system has bash. So typically you'll see bin bash to use that. And then this is basically the absolute path to the bash program, because the bash is actually just a program that's on your computer, just like ls and cd and stuff. It's just another program. And this is where it's located in the Unix system to be able to do that. And so this is telling the computer, when we're going to run this shell script, hey, use the bash shell to run the script. So any file redirections, command line programs, piping, anything we've all learned today can be used in this script. This script will just run command line, will run our commands one by one in a shell, but also giving us access to a lot of stuff like if statements, loops, arrays, all that stuff in a programming language. We'll be able to use all of that, but we'll just make something real easy. So first we'll start off creating this. So let's say I want to echo something. I'm going to use quotes for this because remember, you want to quote our strings as spaces. I'm going to echo hello world. So this is actually going to run this echo and then with this argument, hello world. Now I want to add a comment. I want to add a comment to this piece of code here. I'm going to use the pound. So pound signify comments here. Not to be confused with the pound exclamation point in the first file. This is very special for being the first line in the file. So this isn't a comment. This is part of the shell. But for after that, it's you use pound and then to say, this command echo. So something like that. There you go. So that's a comment. I'm gonna maybe I want this program to print the current working directory. So I want to do print current working directory. I'm gonna tell the user, I'm gonna print that to them. And then I'm gonna run the command pwd to print the current working directory. You can also have variables. So variables are not just like in Python, you don't have to specify variables. You can just create them. So I'm gonna create a variable called my var, and I'm gonna go to the string hello, like that. But to access them, if you guys did some web development like PHP and stuff, you might see some similar syntax here. You have to use the money sign here. So this actually signifies, because my variable is actually the variable kind of like, what's the best word? Like the variable object, I guess. But this my var, but the money sign basically says I want the value of whatever data is in this variable. So that's what this is here. So we're coming up on 12. So let's go ahead and run this real quick. So this is the very first script. It's just going to print pwd, echo some stuff, echo this variable to show some basics of what this can do. So again, to save, I'm going to do Control X, Y, Enter. And now if I do ls, we can see my first script. Now, in order to run it, in order to run scripts or programs from the command line, you're going to use / and then whatever you want to run. So I want to run my script. Oh no, permission denied. It's like, what? Why do I have permission denied? This is my script. Turns out that for executables, you actually have to tell the operating system, hey, this file is executable before you can execute it. So we're going to use this thing called chmod, which allows us to change the permissions on a file. I'm not going to get into depth of what permissions you can do, but this part here, if you do +x as an argument, and then we type in my first script and press enter, this +x will actually mark the script, hey, I can execute it. And we can confirm that when we do ls, it's now green, which means it's executable. And now if I do / my first script, we actually see it. So here we go. So we see hello world. We don't see the comment that's in there. We just see hello world, prints current work directory, and runs the command and then printed hello. And you can run, and again, all these commands and stuff that we learned about, you can put in here. Yeah, that's a very, very basics of a script. It's just, a script is just extra logic surrounding command line instructions that we used before. And like I said, you can do variables, you can do for loops, if statements, all the logic you can do, arrays and stuff like that, and like a programming language.
Quick question.
Yep.
What was the syntax for accessing a variable? Because when I do it, it says cannot find the command.
You have to put the money sign in front of the variable name here.
Oh, maybe it's because I have a space between the equal sign.
Oh, yeah. So that's something I forgot to mention. Yeah, that's something Bash is not like. When you're setting variables, you can't, in other most languages are like, oh yeah, extra white space is fine. Bash is not like white space. It hates it.
Okay, that's good to know.
Yeah. Yeah. So when you're doing my variable, sorry, I forgot to mention this. When you're doing my variable here, you can put enters between, like, it doesn't matter white space between lines, but white space on white space inside a line is very important in Bash, especially when you're setting up like for loops and if statements. So white space, you got to watch your white space because when you do space, it's just like, because look, we have PWE here. This is a command line program. When you add a space here, it's like, okay, I'm gonna look for a command called my var. Well, that command doesn't exist, and it's trying to find the command my var variable and pass it this as an argument to that command. But we don't want that, obviously. So we're gonna use no. When you do no spaces, Bash sees it's like, okay, this is not a command. This is a variable that I want to update here, where it's set to this value. Yeah, so very. Thank you for asking that question. That is very important. So remember with Bash, your white space inside a single line is very important. Inside like one line like this. Yeah, I'll save this and just run this again. Just make sure it works. Yep. Any other questions on this? Anything really? As we wrap up here.
I guess so. I put a comment about that, and it highlighted the word cannot. So like I made the comment, oh, you can't have a space around the equal sign, and it highlighted cannot like it's a
Highlighting.
Yeah, actually, I wonder if I'll share my screen and show you what I mean.
Oh, I think I get it. As long as it's in the comment, it's fine. There's some, I don't actually have syntax highlighting here, but depending on what you're using, you could get some syntax highlighting, which like in Python or whatever, your IDE, have syntax highlighting for your stuff.
Right.
I'm not sure. It's probably just like this. It's not that smart, I guess, and it's not highlighting it, but as long as it's on the line, as long as the line starts with pound, it is a comment, and you can run that to make sure that works.
Okay, yeah, it didn't error out. I just thought that was a little weird that it was highlighting a comment line.
Yeah,
So.
I mean, it depends. It depends on the command line text editor you're using. Because I think if I actually use Vim, let's see, it should highlight. Yeah, so we get some nice highlighting here with the programs and stuff. But it's not that smart, so it'll just highlight it. Yeah.
Okay.
It depends. I want to actually cannot, or you did can't. Yeah, I'm not sure.
Oh, I said cannot.
So can not like that.
No, actually, I did it as one word for some reason. Okay, yeah, Vim isn't highlighting it, so I guess Nano wanted to highlight it for some reason.
Yeah, yeah, that's just an error in the highlighting. Yeah. Okay. All right. Any other questions? No. Well, I hope you enjoyed the tutorial.
Oh, wait, when you do the echo and you have it echo a string, you have to put the quotes around it?
So that's kind of hard to answer. So if you're just doing echo like this, like a line, you don't have to. But if you can actually use echo for some redirection and doing other things. And when you do that, you need to put quotes. So it's just common practice that if you have a string, and especially if it has spaces in it and stuff, you just want to put it in quotes. So it's common. You don't have to in this instance, but you should. Just to keep doing that, because there's going to be instances where it's going to break unless it had quotes. That it doesn't work for everything. So, but in this case, no, we didn't. Like I can just do echo hello world, and it'll work just fine without quotes. But yeah. So any other questions or anything? Well, I just want to say I hope you guys enjoyed the tutorial. It's informative. Like I said, everything I went over is in that GitHub repo, that markdown, the first link I sent. Well, actually, that goes nowhere. Let me send the actual. So everything is in this repo. Also, Robert, we need to update this repo because it's missing the PDFs that were a part of it originally. So I need to add those. But that's everything I went over today is in here in some way that you can look through, except the gzip stuff. I don't know why that didn't happen, but you can use that with any text file. But yeah, you can also look over part 3 and part 4, which I'll be going over tomorrow for Newton and Nakana if you want to get a head start on that tonight. But yeah, hope you guys enjoyed that, and I'll see you guys tomorrow, 10 a.m. for the Newton and Nakana tutorial. And I don't know, Robert, you there? No, he's not.
His name is, but I don't think he is.
Okay. Well, I'll ask him to add me to you. You guys are using Slack, right?
Yeah.
Yeah, I'll ask him to add me to the Slack for you guys as REU, and so I can be made available if you want to just send me a ping about if you need any help or have any questions. So I'll ask him to do that. Otherwise, yeah, thank you everyone. Hope you enjoyed it.
Thank you.
Yeah, thanks, man.
Yeah, no problem. Up, Robert's back. Okay, he's on the phone. All right. I guess we'll wait for him then. He's disappearing. Oh, Dr. Lobo. Okay. Well, I guess how are you guys enjoying REU so far? Pretty good.
It's been fun. It's been a little stressful trying to get everything working, but I know it's been good so far.
That's good.
I feel like I've learned so much already.
Yeah, that's gonna be pretty much the whole REU. It's gonna be nonstop. So yeah, be prepared for that.
I'm just hoping I don't run into any more Python environment issues.
Oh, don't worry. We'll be fixing those tomorrow. Don't worry. We'll get those set up.
Thank
Yeah.
you.
Python environments. Yeah. Once you do it enough times, it becomes kind of second nature. Like you're just good at just setting up environments. But it sucks starting out. It really does. It's you know, Anaconda luckily does a lot of stuff, but you always run into environment issues. It's just, yeah, it's just life with Python. But we'll be talking about how to set up Anaconda and stuff on Newton, which you can also apply locally to your own system for setting up Anaconda. So we'll be heavily using Anaconda. So you can look over the tutorial and stuff if you want to look at that. But Anaconda is pretty good and it's pretty standard. I think of Anaconda and the other one is virtual environment or vert env, but that one is not as robust as the Anaconda. So you'll see pretty much everyone will use Anaconda. I'm sure there's other alternatives, but I don't know about them. So Anaconda.
Yeah, no, it was kind of fun last night after I found out that installing PyTorch overwrote my Keras install and it prevented TensorFlow from using my GPU. And I'm like, okay, this is
because when you install
PyTorch,
yeah, well, obviously you shouldn't be using Keras, but with PyTorch, but yeah, there's GPU and non-GPU versions and stuff like that, and you'll overwrite, especially if you're using your system Python environment and stuff like that's just a nightmare. So yeah, we'll be going over all that tomorrow.
Awesome. Brandon, thank you very much.
Yeah, no problem.
We will plan on seeing you tomorrow morning.
Yep.
Okay, sounds good. Okay, guys, I'll see you in the PyTorch tutorial meeting next. Okay.
Good luck.
all right.
You'll need it.
Yeah.
All right.
Okay, bye.